Alright, this is warm-up 10:14. I'm going to have you on the paper I give you, copy all these words I'm written, all the work, and then the 5 words to show me that you listened. So this first concept is being able to just count to get your numbers for the sequence, and then identify over here which one is the bad function that does not represent that sequence right there. So if I look, step number 1, if I count them, that is going to be 3. Let's close this. Step 1 has 3 circles. Step 2 has 5 circles. Step 3 should give you 7. Remember, you could always pause this to be able to catch up to me to write. Don't try to catch up to me, just pause it. That number that I'm going up by, adding by 2, that is a key number. That is my slope number. That is my, what we call common difference between each number in the sequence. That's my slope number. That is over 1 up 2. That's my rate of change, that slope, the number in front of x. I could use that number to go backwards in this sequence here, which would be step 0. And I would take that and go backwards by doing the opposite of adding 2, subtracting 2. And what am I subtracting 2 from? This 3 number in the sequence right there. So that 3 minus 2 should give you 1. All right, some of you can look over here and see right away that there's only one choice that has a different number in front of x. So that might be a good way of doing it. Maybe before you write your equations, know that this is adding 2. That's your key number. So if you come over here and look, find and make sure all the forms that are good are going to have that 2 in the right place in front of x. Or of course this weird recursive form. First word is fish. Fish. The only one out of these that has a different number for its rate of change is this one right here, 3. And be careful, it matches this 3 right here, but it's not the right one. That one is no good. Of course, you could take the time to write them all first, and then be able to look over there and see which one matches and which one doesn't. All right, next problem. This concept right here, arithmetic, knowing that all these are adding, subtracting. They're always what we call linear. They always give you a straight line. They always have you adding or subtracting by the same number every single time. That's what makes these lines straight, either going up or going down from left to right. Again, straight line, linear, arithmetic. So looking at this one right here, the key, I guess, would be to use 59 and 46 and just treat those as just plain old positive numbers. Subtract them, and you'll see what your rate of change is for this. And then just know for this, you have to add 13. It's not subtracting 13. Adding 13 is the only thing that makes these negative numbers shrink from left to right, which means going to the left, I'm subtracting 13. And again, what am I subtracting 13 from? This negative 59. So that negative 59, if I take it away and combine it with another negative 13, I'll get even more negatives. I'll get negative 72. That's my 0 term right there. So for this, make sure you label as arithmetic. Second word is blue. Label it as arithmetic, and then be able to write recursive. And again, that's not minus 13, that's key positive 13 right there. And then for those of you listening to me, for the explicit form, just focus on 1. And And if I was you, I would take that zero, or not that zero term one, I would take that first term one, so you don't run the risk of messing up and not getting that negative 72. Just use that first term as it is, negative 59 right there. That's where I got that negative 59. That is the first term right there. That's where this is right there. All right, I would be doing it that way, not looking at the zero term. Please, some of you heed my advice. That negative 59 is good to go. Positive 13, not negative 13. All right, next concept is geometric. Geometric is what we call exponential, which is not straight. It is curved line, not a constant rate of change. You're going up by a little bit and then by a huge bit. It's not a constant rate of change. So for this, to find the number you're multiplying or dividing, I would focus on these last two pairs down here, the smaller pair, and just divide it out. Divide the bigger one by the smaller one, and you'll get the number that you're dividing by. You're dividing by 3. But remember, the way we show this, we don't show dividing by 3, even though that's what I'm doing. I'm taking each of those numbers and dividing by 3. That's where I'm getting those numbers. My next number in my sequence, for those of you listening, would be 8/3, and then that time would be another 8/9. But that's a whole other thing. You need to just know that for this, we don't show dividing by 3. We show dividing by 3 as multiplying by the reciprocal. So that's one big concept in Math 1 that throws some people for a loop. We don't show dividing by 3 in geometrics. We show dividing 3 as timesing by 1/3. And then listening to my advice, I would jump right into my equations. I have my recursive form. Next word is dog. Dog. So recursive form, and that's going to be key timesing 1/3, not division, timesing 1/3. And then using my advice here, I'm going to use that first term, which is that 216 times that 1/3. But remember, when you're using that first term, the weird part is you got to write that as to the x minus 1 power. So again, try to listen to my advice. Use the first term when it comes to these two problems, arithmetic and geometric. Just deal with that little weird x minus 1 that is not over your ability. Use the first term. All right, last concept is parts of an equation, and then of course discrete, which are dots, versus continuous, which is a line drawn through the dots, continuous data, exponential curved versus linear straight. All right, so here you go. If I give you the amount of money in the bank or a deposit, same thing. That is your zero-term number. That is your y-intercept. That is the zero term. That is when you're writing this 0, 300, how much you have at the very beginning. After one day, increasing your total by 200 because you're earning 200 a day, your first term would be 500 right there. That's how much money in the bank now. After 2 days, up to 700. 3 days, up to 900. All right, but for this, writing the function with whatever letters you use, you always put that rate of change number, that 200. That is your rate of change. That would be how much you're earning. That would be your monthly rent. If it was paying monthly rent each month, that would be your rate of change number right there. And of course, your y-intercept term, your 300, is how much you have at the zero time, at the beginning, at the 0 part of the graph. If you were to graph this, it will go up to 0, 300, and then be a straight line from there. So knowing that again, this number in front of X, your rate of change, is your rate of change monthly rent. That would be the number for earning each day. And then of course this right here is your deposit. That is your y-intercept. How much you have at the 0 term. 0 for X, 300 for Y, the y-intercept. All right, next word is bird. One more word. One more word. All right, now graphs. If it's dotted, it's going to be discrete. Actually, you know what? Yeah, let's just do it in that order. So continuous, a line drawn through it, or dots, no line drawn through the dots. So this one is definitely discrete because there's no line drawn through the dots. It is a linear pattern going straight. So again, you have two categories, dots or no dots. And then the next category after that, curved or straight. Those are your two categories, dots, discrete, or no dots, continuous. So here we go. First category, dots, discrete, no dots, continuous. This has no dots, line drawn through it, continuous. Going to the next category, curved or straight. This is curved, exponential. All right, look the next one down. First category, dots, discrete, or no dots, continuous. This has no dots, continuous. And then curved, straight, curved, exponential. Next one, dots, no dots. This has no dots. Remember, if this was gone, and there were just dots, that would be discrete. But because there are no dots there and a line drawn through it, that's why we call this continuous. And then of course that pattern makes this linear. Exponential is curved. Last word is wave. Wave. All right, talk to you in a bit. Good luck. First one to give me thumbs up, give you a little extra credit for listening. Good job.